Hello, I'm Betty, a math educator from South Carolina. I'm here with Judy, a math educator from Colorado. We're going to explore the vertex form of a quadratic function. This is based on an activity located at 84 Activities Central in the education.ti.com activities section. It's called Graphing Quadratic Functions. To explore the quadratic function with the vertex form in this activity, we're going to think about what vertex form looks like. The vertex form of a quadratic function, as you see on the screen, a multiplied by x minus h squared plus k. The vertex is hk. So Judy's going to record there our vertex in this form. We can easily identify xk. The axis of symmetry is a vertical line that would go through the x value of the vertex, about which the parabola, the graph of the function, is symmetric, x equals to h in this case. The transformation graphing app on the TI-84 allows us to use a, b, c, and d as our parameters, so we'll be entering the equation shown below. Vertex, therefore, is the ordered pair b, c, and our axis of symmetry has the equation x equals to b, the x value of the vertex. To enter this in our transformation graphing app on the TI-84, we'll first press the apps key. You may arrow up or down and choose transform. When we go to the y equal option, things will look a little bit different in the y equal menu. And we're going to enter the equation in y1, the vertex form. In this case, a multiplied by x minus b, quantity squared, plus c. We chose a zoom decimal window, and as you can see, currently we have the parent function graphed since a is equal to 1, b is equal to 0, and c is equal to 0. So if you substitute a is 1, b is 0, c is 0 in the equation at the top of the screen, the result would be y is equal to x squared. Judy is going to change the value of a. We'd like you to think about the three questions on the right as she does this. So that you can watch the screen, I'll read those questions. As a changes, what do you observe about the vertex for each of the parabolas? How does the value of a affect whether the graph opens up or down? And how does the value of a affect the shape of the graph? Think about those for just a moment. In another video, we explored the effects of the changes in the value of a. Let's review those effects. On the next page, we have a summary of what we have observed in another video. If a is greater than 0, the parabola opened up. If a is less than 0, the parabola opens down. The vertex of each of these parabolas is at 0, 0. You may have noticed when Judy changed from positive to negative and the a value was equal to 0, there was not a parabola. It was not a quadratic function. So a cannot be equal to 0. That would be the graph of the horizontal line, y is equal to 0. If the absolute value of a is greater than 1, it's a vertical stretch. It becomes more narrow. Compared to the parent function in this case, the y values are increasing more rapidly. If the absolute value of a is between 0 and 1, we have a vertical compression. Compared to the parent function, the y values are increasing less rapidly. Notice when Judy enters values such as 2/10, we can see that, or 1/10. So we have a vertical compression. Let's now consider changes in another parameter. We're going to go back and change the a value to 1. C will remain 0. And this time we're going to think about, with respect to the parent function, what happens when the value of b is greater than 0? What happens to the graph? If Judy's going to use the right arrow key to increase the value of b. She's going to keep the value of b positive. Notice she could also type a value that's not an integer. For example, she could enter 2.5 for b. And you can still see the change in the graph there. Let's think about what would happen also when b is less than 0. Perhaps she'll enter -2 for b, negative value, and then she's going to continue to show some negative values for b. We'd like to ask you to pause the video and respond to these two questions on your right. When you've had a chance to write your responses, please return to the video. You may have noted that when b was positive, and Judy will enter a value, perhaps, she can just move to the positive values. That's great. So when b is equal to 2, of course, and other positive values, the graph shifted to the right. We had a horizontal translation to the right. Also, the vertex changed. At the location you see on the screen right now, when b is equal to 2, rather than at 0, 0, the vertex is now at 2, 0. It is shifted to the right 2 units. You could confirm this algebraically. When the value of b is negative, hopefully you saw that compared to the parent function, the graph was shifted to the left, horizontal translation to the left. In this case, when b is -2, our vertex is now at -2, 0. It's moved to the left 2 units. Again, you could confirm that algebraically, computing the vertex. So now we're going to change b back to 0 and consider now what happens when the value of c is changed. Judy will be using the right or left arrow in the transformation graphing app to change the value of c. As you observe the changes, think about what you observe about the vertex of each of these parabolas as c changes. And also in general, how does the value of c changing affect the graph? Or how does the value of c in general affect the graph? Please pause the video, write down your responses to these two questions, and then return to the video. Hopefully you noted that when c changed, the vertex changed as well. In the example shown right now, where c is equal to 1, it appears that the vertex is at 0, 1. Our axis of symmetry would still be at x equal to 0. And again, you could confirm this algebraically by entering 1, 0, and 1 respectively in for a, b, and c. Then we could also think about the shape of the graph is not changing, but the value of c definitely affects the graph. There is a vertical translation. If c is negative, it is moved down with respect to the parent function. If c is positive, the graph is shifted up with respect to the parent function. Let's now put all of this together. On the next page, you're going to see a situation where a is equal to 2, or a description of a quadratic function. A is equal to 2, and the vertex of this quadratic function is at -4, -3. We'd like for you to write the equation of the quadratic function in vertex form. Please pause the video, and once you've written your equation in vertex form, please return to the video. Let's go ahead and write this equation. Hopefully you started out with f of x, or y in this case, since we're using the transform app, will be consistent there. The a value is 2, multiplied by x minus the x value of the vertex, plus k. And in this case, Judy's going to put plus a -3. And then if we simplify this a little bit, we could write y equals x plus 4 quantity squared minus 3. Let's see how that graph looks. Since A is equal to 2, Judy can go and change the A value to 2, and we see it's more narrow than the parent function where A was equal to 1. The X value of the vertex, the B value in this case, is -4. We should have a horizontal shift 4 units to the left, and the C value is -3. So compared to the parent function, there was a vertical shift 3 units down. Hopefully your equation looks like the one at the right. Now let's have a challenge. We'd like for you to describe the graph shown on the next page, the graph of the function rather, shown. So this function is y is equal to -2 multiplied by x minus 5 squared plus 4, quadratic in vertex form. Describe the graph of this function when compared to the graph of the parent function. If it would be helpful, sketch your graph, of course. You could record the vertex, the axis of symmetry, and any other attributes of the graph. For other videos, please go to the TI Education YouTube channel.